Okay, theoretical and experimental probabilities. When you conduct an experiment, the relative frequency of the event is the fraction. It's the number of times the event occurs over the number of times you performed the experiment or you conducted the experiment. So the number of times it happens over the number of times you try to make it happen. All right, so when you're flipping a coin, if I get heads 3 times and I flip that coin 6 times, then it's actually 3 out of 6. So 3 times out of 6, I got that. I got heads. If I flip a coin and if I'm looking for tails and I got tails 4 times, but I flipped that coin 10 times, then it is going to be 4 times out of 10. That's relative frequency. All right, so experimental probability. It is based on repeated trials of the experiment. And it is the event, probability of the event equals the number of times the event occurs over the number of trials. So if I roll a die and I am trying to get an even number and I roll it 16 times and I get an even number 6 of those times. I'm looking for an even number, I got it 6 times out of 16. That is experimental probability. You actually have to do the experiment. All right, so the bar graph shows the results of rolling a number cube 50 times. So I rolled that cube 50 times. I did that experiment 50 times. What is the experimental probability of rolling an odd number? So my odd numbers are 1, 3, and 5. I rolled a 1 10 times, and a 3 8 times, and a 5 11 times. So 10 plus 8 plus 11 is 29. So the experimental probability of rolling an odd number was 29 out of 50. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So my experimental probability is going to be 2 out of 12, because it's rained 2 days out of the 12. But if the trend continues, how many rainy days would you expect in April? So there are 30 days in April. Okay, and so I can actually solve this as a proportion to guess how many times it should happen, how many times it should rain in April. It's no longer experimental probability. This part is the experimental probability. This one is your educated guess of how many times it's going to rain in April. So you can solve for that and see what you think it's going to be. All right, theoretical probability. It is when the possible outcomes are equally likely. So it says number of favorable outcomes over number of possible outcomes. We already talked about this with probability in our probability video. So if I have a die, there are 6 sides to that die. And I say, so the number of possible outcomes is 6. 1, 2, 3, 4, 5, and 6. And I say, what is the probability, the theoretical probability that I would roll an odd number? That's going to be 3 out of 6. 1, 3, and 5. I'm not performing the experiment, I'm just saying how many times it should happen. All right, so you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So I have 1, 2, 3, 4, 5, 6, 7 different possible outcomes, or 7 possible outcomes. Okay, I can get this E, I can get this E, that's 2. I can get the X, the L, the O, the P, or the R. Now, what is the theoretical probability of choosing a vowel? I have E and O and E, so it is 3 out of 7 is the possibility of choosing a vowel. If I said possibility of choosing an X, it is going to be 1 out of 7. If I say possibility of choosing an E, It is going to be 2 out of 7. All right. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1 in 6. Is your probability of winning a bobblehead. The wheel has 3 bobblehead sections. How many sections are on the wheel? So this is my theoretical probability. It is actually simplified down. If I would have simplified, I can't simplify that one down. If I would have simplified this one down, it would have been 1/2. You divide top and bottom by 3. That is the same probability. All right, so I don't know how many bobblehead sections there are. Sorry, I do know how many bobblehead sections there are. There are 3. I don't know how many total sections there are on that wheel. So I can just put a variable there. And I can solve for this variable. 1 times x is x, and 6 times 3 is 18. There are 18 sections on the wheel. All right, the bar graph shows the results of rolling a number cube 300 times. So we are talking about experimental probability. What is the experimental probability of rolling an odd number? We are rolling 300 times. What's the probability of an odd number? We have 48 there for 1, we have 50 there for 3, and we have 49 there for 5. So here we have 99 plus 48, 157. Did I add that right? Yep, 157 is your, 147. 147. 147 out of 300 is the experimental probability of rolling an odd number in this experiment. How does the experimental probability compare with the theoretical probability of rolling an odd number? So my theoretical probability is, going to be, I have 6 different possible outcomes. Okay, I don't have 300, I have 6 different possible outcomes. And the probability of me rolling an odd number is 3 in 6, or 1/2. So I can compare these. If I have 1/2 and I am comparing that to 147 over 300, I know that 1/2 of 1/2 of 300 is 150. So that would be my theoretical probability in this case. That is actually really, really close. So they are very, very similar. It's 3 off. And then compare the experimental probability in part A to the experimental probability in example 1. Let's see. Example 1, let's go back. One more. Okay, example 1 was this bar graph here. We rolled an odd number 29 out of 50 times. So 29 out of 50. I know that 1/2 of 50 is 25. So theoretically, it should be 25, but it is 29. So my experimental probability is greater than my theoretical probability. But once again, they're fairly close. Not as close as this one here, but they are pretty close. And that is experimental and theoretical probability.